Hello and welcome to Learn Yourself. Today we are going to talk about change of state. This topic is under CBSE Standard 9 from the chapter number 1. So we all know that there are three states of matter: solid, liquid and gas. They all can change in each other by changing temperature and by changing pressure. So in this video we are going to discuss about that how the one state can convert into another by the application of heat or by the application of pressure. So first of all, matter can change its state by changing temperature. That means we can rise the temperature or we can lower down the temperature. By doing both, the matter will change its state. Regarding pressure, it's the same, that by applying pressure, by giving pressure or by taking out a pressure or by removal of the pressure, we can change the state. That we will discuss, the both effect we will discuss in detail. We all know that solid. Here we are going to take one example of ice. As a liquid we are going to take water, and as a gas let us take steam or vapor. So when solid is converting into liquid, we have to give heat. So by rising temperature, by giving temperature, the ice will change into water. Now water will change into vapor one more time when we are giving some more heat. Then when the reverse thing will happen, when the gas, the vapor will cool down, it will become a liquid. Then liquid will cool down and it will become solid. That means when temperature is rising, the ice will become water. When temperature is rising, the water will become vapor. By increasing temperature, this change will happen. Now by decreasing temperature, the temperature will decrease and vapor will become liquid water. Now temperature will decrease and liquid water will become solid. So this will happen because the increasing of temperature and decreasing of temperature. The same thing understand with the help of carbon dioxide gas. By giving a pressure, it will converting into a solid, and by removing a pressure, it will again change it to gas. So these two changes we are discussing in detail. So we all know that interconversion of state of matter is like this. That solid will convert into liquid, liquid will convert into gas, and sometimes solid will directly convert into gas, and interchanging of this also is possible. That ice can be water, water will become ice, and so on. So this is known as interconversion of states of matter. Now we are talking about when solid is converting into liquid. So you please put an example in your mind that ice is converting into water. We are talking about that phenomenon. That when ice is converting into water, what will happen and how it will happen. How it will happen we'll discuss first. That this is ice and we are heating it. So we are giving energy. We are giving energy and its temperature is going up. So this ice is becoming water. By giving energy, by giving temperature, this ice will become water. So its state will change from solid to liquid. Now when we are giving a temperature, what will happen? The kinetic energy increases. We know that all the states particle do have kinetic energy in them. Solid vibrates at their position, liquid can move, and gaseous atoms have maximum kinetic energy. They move randomly, freely. So when we are giving energy in terms of temperature, the kinetic energy of this ice cube, of this particle of this ice cube will increase. The Ke meaning kinetic energy of this particle will increase. The particles start vibrating with greater speed. They are fixed in their position because they are in solid state. So they are vibrating, but now they are vibrating at greater speed because we are supplying energy. We are supplying more kinetic energy to that. That energy is, we are supplying temperature, we are supplying energy, and that is converting into kinetic energy. So now they are moving with greater speed, and this speed will overcome. This is very important point, that this speed of particle will overcome the force of attraction. Why they held into this ice cube? Because of force of attraction. Now when we are supplying energy, it is converting into kinetic energy, then their energy is becoming higher. So now they are vibrating at greater speed, and this, because of this speed, it will overcome the force of attraction. And the particles will leave the surface. Slowly from all the side of the ice cube, the particles will leave its surface, its original position. All the particles will leave its original position and starts moving freely. Earlier they were in the compact closed structure. Now they will start moving freely. At this point is known as melting point. Why melting point? Because solid, at this point solid is converting into liquid. So what will be the definition of melting point? At the minimum temperature, at which minimum temperature the solid will start converting into liquid at fixed atmospheric pressure is known as melting point. That definition we will see it in a detail. So this is a definition of melting point. That the minimum temperature at which solid melts to become a liquid at the atmospheric pressure is called its melting point. So we all know that we can change a state of matter via two things, by applying temperature or by applying pressure. So here we are talking about temperature effect. So we have to write that at minimum temperature at which solid melts to become a liquid, solid is converting into liquid by giving temperature. At the atmospheric pressure, that means we are not changing pressure. Whatever pressure is there in the atmosphere, it will remain the same. So we are not applying pressure, but we are giving temperature. So it is known as melting point. So here we are clearing the point that by giving a temperature, and that a minimum temperature, solid is changing into liquid. That minimum temperature is known as melting point, and it should be at the atmospheric pressure. So this is a definition of melting point. So after melting point, now we are talking about latent heat of fusion. So before discussing that, let us understand one activity. That I am heating this beaker which is filled with ice cube. I am heating this and I am continuously checking the temperature of the content in the beaker. So while I am passing a temperature, while I am giving an energy, when this ice is becoming water at certain point of time when it starts, after that this temperature change, my thermometer will not show. That means the temperature will rise until the ice will start melting. After that, the point when the ice has started melting and it has becoming liquid, until the next state will achieve, that water from ice, it will become water and then it will become vapor. So when this will start, here for example it has start melting. So till now the temperature will rise, but once this has start melting, the temperature will remain constant. Even though we are giving a temperature, even though we are giving energy, we cannot see any rise of the temperature until each and every ice will melt. One more time I am explaining. When ice is becoming water, throughout I am heating it, throughout I am giving a temperature. Temperature will rise until its melting point will arrive. When we are achieving its melting point, till that time my temperature will increase. I can see that through thermometer. Now once the melting of ice will start and each and every ice will become water, my temperature will become constant. Even though I am passing an energy, even though I am giving continuously temperature, then also the temperature will remain constant. So the question is where that energy has gone, because we are passing a temperature, we are passing energy continuously. Even after reaching melting point, then temperature should increase after that, but it is not happening. So now we are discussing that why temperature is not increasing and where that energy will go. This energy, this heat, we know as a latent heat of fusion. So when ice is melting, as this heat energy, now whenever we are talking about energy here, you have to assume that the heat energy, the heat we are giving it to the beaker. As this heat energy is absorbed by ice without showing rise in the temperature. That means all the ice cubes will absorb that energy, and that energy they are utilizing and giving it to the particles, and that particle will get that energy and make themselves free and they will become water. These things we have seen while we have discussed the melting point. That we have seen that how the ice will become water. That it will overcome the force of attraction. How it will overcome the force of attraction? With the help of this energy. With the help of the increase in kinetic energy, they will overcome the force of attraction. So as this heat energy is absorbed by ice without showing rise in temperature. So we cannot see any rise in temperature. It is considered that it gets hidden into the contents of the beaker. Contents of the beaker, that means it is hidden into this, hidden into half of the water, half of the ice, because the fully ice has not been converting into the water. At this stage we are talking about this hidden energy, because still ice is converting into water, so it is utilizing that energy, but we cannot, so that's why we cannot see any change in the temperature. So this is all about a discussion of latent heat of fusion. Now we will see its definition. The amount of heat energy. The energy we are talking about, that is heat. The amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure. Why we have to mention this atmospheric pressure? Because all this process is happening is by changing of temperature. We are not changing pressure. So that's why it is important to mention that at atmospheric pressure. At its melting point is known as latent heat of fusion. So at melting point, this is our melting point. So at melting point, whatever energy we are giving, once the melting point has reached, after that, whatever energy we are giving to dissolve 1 kg of ice. Here we are talking about in general, solid. So I am explaining you with reference of ice. Once the melting point will reach, whatever energy we are giving, that energy is utilizing to dissolve 1 kg of ice into water. That energy is utilizing to melt 1 kg of solid is known as latent heat of fusion. In a simple way, if I tell you that once the ice will start melting, at this point, even if we are giving a temperature, the temperature, increase of temperature we cannot see in thermometer or wherever we are checking. Why? Because that energy the solid particles are utilizing to overcome force of attraction. That energy we call latent heat of fusion. So if you feel that this video has cleared your doubt and helped in your learning, please give us a like, subscribe my YouTube channel, Learn Yourself for more important videos and content. If you have any doubt, any question, or if you want to share anything, please do write us in a comment box. Now let us discuss some of the important points in latent heat of fusion. Particles of water at 0 degree centigrade have more energy as compared to particle in ice at same temperature. Why we are discussing that? Because we are comparing that in solid particles have more energy or in liquid they are having more energy. So obviously the energy level of particles in solid is less than liquid, and the energy level of liquid particle is less than gaseous particles, because here they are in a closed compact structure. Their energy level is very low. Here they have some energy, they can flow, and here we can observe a random movement of particles. They have very high energy. So particle of water at 0 degree centigrade, because this is the form of liquid, have more energy as compared to particle in ice at the same temperature. Even the temperature is same. One is water, one is ice. So definitely the particles in water will have more energy compared to the solid state. Now we will see a definition of boiling point. This is a definition. Earlier we have seen a definition of melting point. The same way we are writing definition of boiling point. The temperature at which a liquid starts boiling at atmospheric pressure is known as its boiling point. When it starts boiling, at that temperature is known as its boiling point, and it has to be at the atmospheric pressure. Then boiling is a bulk phenomena. Why is a bulk phenomena? Because whenever you are seeing that water is bubbling up into the vessel, the whole lot of water, whatever water you have taken, is together it is boiling. You cannot see that some of the water is boiling here and some of the water is still in the process of getting energy. That means it happens to the lot. Now water vapor at 100 degree centigrade have more energy than water at the same temperature. Absorb latent heat of vaporization. So what is the meaning of this? That water vapor has more energy compared to water. Obviously this is a gaseous state and this is a liquid state. This is a gaseous state, this is a liquid state. This particle has more energy. Why? From where they got the energy? By absorbing latent heat of vaporization. they have more energy. If you will think about this, here they have absorbed latent heat of fusion. So that's why they have more energy. And here they have absorbed latent heat of vaporization. That's why they have more energy. Now let us take one quick recap of while we are changing a temperature, how the state will change and what all terms we have learned till now. So we have seen that definition of melting point and boiling point. So let us recall that when solid will convert into liquid, liquid will convert into gas. When solid is converting into liquid, it is melting. When liquid will converting into gas, it is vaporization, that we are learning. Then solid will convert into liquid when it start melting. At this temperature we known as melting point. When the ice will start melting, that temperature is known as melting point of water or ice. So now when a liquid start boiling, that temperature we known as boiling point of that liquid. Now when solid will start converting into liquid, after that whatever energy is being absorbed by the particles, and particles will become free. From solid it will become liquid. So this particles are free compared to this particles. So what all energy they are absorbing and becoming free is known as latent heat of fusion. And until all particles will become free, this will not show any temperature change. So we are saying that at 0 degrees centigrade, water particles have more energy compared to ice. Because this is a liquid, those particles are free compared to solid state. And why they are free? Which energy they have absorbed? They have absorbed latent heat of fusion. Now when we are talking about that liquid will convert into gas. That means when water is boiling, it is converting into a steam, and we are seeing that it is changing its state to vaporization. So at 100 degrees centigrade, vapor has more energy compared to water particle. Which energy they are absorbing? They are absorbing latent heat of vaporization. So until all the water will go to the next state, this will not show any temperature change. Why? Because all energy is being absorbed by the water and it is converting into vapor. So vapor has more energy compared to water. Which energy they are absorbing? They are absorbing latent heat of vaporization. So all these four terms are interlinking with each other. First you can see melting point. Then after that what will start? Latent heat of fusion. Then you can see boiling point. After that what will start? The latent heat of vaporization. And 0 degree centigrade, water particle has a more energy because they are absorbing this. At 100 degree centigrade, vapor has a more energy because they are absorbing latent heat of vaporization. So do you feel that this video has solved your doubt regarding latent heat of fusion and vaporization? If so, then please give us a like, and if not, then please do write it in a comment. Whatever your doubt is, whatever your question is, I'll try to help you out. I'll make a video based on that. And please subscribe to my channel for more important videos. Stay tuned for more important content, and I'll see you in next video.